Welcome, Sebastian. You're going to be talking at PHP UK in February 2026, and your talk is testing and documenting event-based software. So for people who don't know what event-based software is, what is it?
That is a good question. That is, at least for me, really hard to answer without resorting to the hello world example of event-based or event-driven systems, which is that of a bank account. I really hope that nobody thinks that a bank account in a banking environment, in the software for a financial institution, is implemented in such a way that it only stores the current balance. Right? So for hundreds of years, if not longer than that, we have had a really good approach, at least I think so, of dealing with accounting information in that we record transactions. So at some point, somebody opens a bank account and the balance usually is initially zero. And then you make a deposit and the deposit is recorded. Like, this has happened. And this thing that has just happened, this record that has been made, that is something that is always formulated in the past tense. Something has happened, and that is an event. And our entire world is made up of events. And we as human beings are used to thinking in events. And one of the things that really surprises me a lot is that it took us in software engineering such a long time to realize that if we start thinking in events, it suddenly, at least for me, becomes a lot easier to map concepts from the problem space, from the domain, from the business to software, and represent ideas and concepts and rules from the real world in software. And once you have this single source of truth that is your log of events, a lot of things become very easy. For instance, auditing suddenly becomes very easy because you already have your audit trail. You have your event log. This account was created then this amount was deposited, then this amount was withdrawn, then this wire transfer was made to this other account and whatever. You have that history. And that gives you features like an audit trail for free, but it also makes testing such a software a lot easier. Because if you build a traditional, whatever you want to call it, CRUD-based application, you always deal with state. Like, the database has to be in this state so that I can start doing my test, and then I call the piece of code that I want to test, and then I need to inspect the current state of the database. And all of these is very tricky, very tedious, error-prone, and slow, and not really maintainable, because the fixture that you start with needs to be written down in a way that makes sense for the persistence layer, for the database that you use. And also your test oracle, meaning the concept that you use to decide whether or not something was correct, that you implement using assertions, also needs to operate on this persistence layer. And again, that is at least complicated, if not really, really hard to work with, because it's a different way of thinking than what is natural to how we, or at least how I would like to think about systems. And if you have an event-based system, writing a test becomes as easy as, given these events have happened in the past, given somebody created a bank account and deposited 10 euro, when I now request from the system the current balance, then I see this is the current balance. Or slightly more complex, not complicated, given these events have happened in the past, when I perform this command, for instance, withdrawing money, then I expect these other events to have happened now.
I see. So actually, the testing element of doing event-based software will become much simpler on the back of this. I do find this really interesting, because I always think whenever you've got something that's difficult to test, it's nearly always an architecture problem, isn't it?
In a lot of cases, I would say yes.
And yet, I would say, I don't know, I'd be really intrigued how many PHP projects are event-based software and how many of them are CRUD with a lot of layers of argument or CRUD on top of it, which makes things difficult. So actually, this is more. Is it more about how you architect your code for certain problems to make the testing easier? This talk, or is it, considering we've got a event-based software system, this is how you can write the test for it?
So for me, that is hard to answer, not because it is a hard question, but for me, there are a lot of what other people perceive to be separate problems are for me just separate sides of the same coin, if you will. Like, I really like to think in the terminology of these events, because as I mentioned earlier, that is just the natural way of thinking. At least I think so. And it helps probably in all phases of software development, but I can give you some concrete examples where it helps. So for instance, I really like collaborative modeling, which is an approach to figure out, for one example, it's easy. It helps with figuring out what is the software that we want to build. Yeah, and that is a moderation technique, if you will, where you bring the relevant stakeholders into a room, give everyone a lot of sticky notes, and tell them to put the sticky notes on the wall, documenting either the current, like depending on the context, the temporal context of the project. Are we starting something new? Then you obviously model the system that you want to build. Or if you want to modernize or extend an existing system, then you can use this approach to model the existing software. And no matter which of the two approaches I just explained you do, there are always surprises, because rarely the current system behaves exactly like all stakeholders in the room assume it to behave, right? So you have color-coded sticky notes, usually orange for events. And in the first phase, you just try to come up with all, like, brainstorming, figure out what are the relevant events in our system. And you put them on what is called an infinite canvas on the wall. Of course, in the real world, nothing is infinite, but usually it's like an entire wall, and you put it there. And then you start clustering events, you deduplicate, you put order in, and you soon start to see, okay, before I can deposit an amount, to stick with the example from before, an account has clearly have to be created at some point in the past. So you see a logical temporal order of some of these events, and you start seeing where events need to be processed, like events that have happened. You have pieces of software that act on events that happen as they happen, to either do side effects like sending out an email or printing something or do whatever, or to emit other events, again, that are then maybe consumed by other parts of the system. So from an architecture perspective, this is a concept of decoupling different parts of the system from each other.
Okay. And so I can understand we have got bits of code that say I act on these events and then I do something with that, send an email. But if one of the actions is I then dispatch another event, which presumably another bit of the system will then pick up on. Do we still need tests? Well, I've got like a bit of code A, bit of code B. A, emits events that B then consumes. Would we then have a test that kind of encompasses both A and B just to make sure they're connected up correctly? Or is it so simple we don't need a test for it?
The short answer is yes. The slightly longer answer is that I prefer to test as much of all of what I just described in isolation from the side effects and from infrastructure components like an event store or an event bus or a message queue or whatever you need as a technical implementation detail to make it work in the broadest sense. But in addition to these isolated unit tests that test, hey, I have this command processor whose single responsibility is to process one type of command that is made against the system, acting on information in the form of events that happened in the past. And the result of that command is that in the simplest form, one other type of event is emitted. That is really beautifully testable in isolation from all of the other things. And you can use the tests for this command processor to document your system. That is the core idea of what I would like to talk about at the conference. But in addition to that, you of course also need larger tests that make sure that the system works as a whole. Yeah, because there's a difference between building the system right and building the right system. And you need the small tests to make sure that the isolated units of code work correctly. And you need the larger tests to test whether or not everything has been integrated properly and if a workflow as a whole actually generates the value that the customer or the user of the system wants to get out of it.
I see. So we do have, and predominantly, I assume, most of the tests, as in number of tests, will be around like the isolated unit, and then we have a smaller number of tests, but to check everything is kind of connected together properly, and the workflow executes.
In a nutshell, yes.
And I imagine that even though there could be orders of magnitude more of the smaller tests, they'll run a lot quicker than having everything.
The smaller the test usually means the less code to run. The less code you run, the quicker the test is to execute and the more precise is the feedback that you get from it. Because when a test only executes like 10 lines of code and it fails, the root cause for that failure can only be in that 10 lines of code. So you get both benefits. It's really quick to execute, takes a couple of milliseconds to run. And when it fails, you get precise feedback so you can skip on using a debugger and know exactly, it's these 10 lines of code. I look at that, I can fix the issue, run the test again, done. That's my feedback loop. The larger the test is, the slower the test will get to execute because on the one hand, you run more code and a lot of more system parts are involved. There's probably the event store or the database or what other kinds of external systems that you need to interact with. I mean, software development would be a whole lot easier if we did not have any input, any output, any side effects. It would also be a lot more boring than it is because such software would not be useful. Right? So the larger the tests are, the slower the test will be to execute, and the less precise the feedback will be when it fails, because so much code is executed and the root cause for that can be anywhere. But, and that is the good news, in almost all the cases, if a large test, like the one that I just described, fails, you have at least one small test that is also failing at the time.
I see. So you run all your small tests first, presumably?
I do run the small tests first, and I even go one step further. And before I run my small my unit tests with a tool like PHPUnit, I do static analysis to rule out other types of errors before I even get to running dynamic tests. So these days, I first run PHP stan, and if PHP stan tells me through static analysis that the code does not have a chance to properly run, I do not even bother running the unit tests. So it's a step-by-step approach. Static testing, small unit tests, integration tests, end-to-end tests for acceptance testing.
Yeah. And I suppose everyone knows, but for those who don't, you are the author of PHPUnit. And for people that don't know what PHPUnit is, I mean, like very quickly, what does it do?
Do you want the funny answer or
I'll have the funny answer. Yeah.
The funny answer would be it is the result of a bet with one of my professors at university that I had like 25 and a half going on 26 years ago.
Yeah.
Right. So back then I was still studying computer science. We were doing some Java at university, and one of my professors was friends with Erich Gamma and Ken Beck and others, and really early on got JUnit, got interested in that, and passed his interest and his enthusiasm about testing and unit testing in particular to us students. And he knew that I was involved in the PHP project, that I was doing open source, that I was here and there fixing bugs in PHP and working on things like the reflection API for PHP 5 and things like that. And he thought, well, there's nothing like JUnit for PHP. And he clearly saw that I was interested in that. And he thought, can I finally convince you now to do Java and JUnit, because JUnit and testing? And I may or may not have said, well, just because it doesn't exist yet doesn't mean it can't be done. And next week after that, I showed him a prototype of what would later become PHPUnit. But only a year later or so, I dared publish that, because by then I was still hoping that somebody else would also run into the same problems that I was running into, because I wanted to have automated testing for my PHP projects at the time. And I thought clearly others are more suited to start a project like that, to maintain a project like that than me. And for at least a year or so, I did not dare publish that. And then at some point I just said, okay, it's painful to not be able to work on this with proper tooling. I mean, this was 26 years ago. That was like 5 or 6 years before Git.
Wow.
Version control, like getting public version control at the time was rather tedious. It was before GitHub. It was probably the only option that you had was SourceForge. And somebody had already created a project named PHPUnit on SourceForge, but it was not working. So that name was blocked. Wow. But I wanted to call my tool PHPUnit because to me it made sense. Yeah, all of this started with SUnit for Smalltalk by Kent Beck, and then Erich and Kent created JUnit. Then Michael came along and did CPPUnit, and then came PHPUnit. And I wanted to have that same name, and just using a different name just so that I could get it on SourceForge didn't make sense to me. And around that time, and I do not know whether that was intentional or not, I got the credentials and role to create new projects on cvs.php.net. So I just created PHPUnit there in the pair project, which was started at the time, and just put it there so I could have version control. And yeah, as silly as that sounds, the rest is history, because 25 plus years later, I'm still maintaining this. Yeah. There are dozens of millions of downloads every month. And basically every professional PHP developer in the world is using PHPUnit to test their software.
Yeah. Because even other testing tools are all based off it, aren't they?
Yes.
You know, a lot of them are. Yeah. So just think, there was you 25 years ago praying that someone else would start on the PHPUnit thing, and then you did it. So there could have been like 4 or 5 other people going, "Thank God, Sebastian's done it. We don't have to."
Maybe, I don't know.
What happened to the? Do you know what happened to the PHPUnit thing on SourceForge then? Did that?
It's like last time I checked, that was a couple of years ago, it was still there and it's unchanged since I looked at it in 2000.
Wow.
So I tried using that in 2000. I could not get it to work with either the current stable version of PHP 4 at the time, nor with the development versions, the development snapshots of PHP, what would later become PHP 5. But yeah.
Yeah. I mean, honestly, PHPUnit it's such an incredible tool to have the ability to write tests easily. So thank you very much for all of the work you've done on it to you know, from day zero really. And there might be people watching this and think, well, I use PHPUnit, and how can people who use PHPUnit and benefit from PHPUnit, how can they support you to, you know, keep it going and to say thank you for all the work you've done so far? Are there any mechanisms for that?
There are 2 main mechanisms for that. One way is to just sponsor my open source work on PHPUnit. And that is possible through platforms like GitHub Sponsors or Thanks.dev or LiberaPay. And that's for individuals, that's the easiest way because it's just 1 or 2 clicks, and that gives me like a monthly amount. And most of my donations come from individual developers giving me like $1, $3, or $5 a month. And I appreciate that a lot. For companies, for corporations, it's usually easier to approach me directly and get an invoice from me, which gets them then their logo in return on the PHPUnit website. So that is one opportunity to do that. There's a different way of supporting me that also benefits you and your team, and that is contracting me for consulting, coaching, and training. That is what I've been doing now for 20 plus years, to put a roof over my head and food on my table, because, spoiler, GitHub stars don't do that. So all I do professionally is knowledge transfer, know-how transfer. I don't do contract development work, for example, but I do consulting, coaching, training, helping teams make better use of PHPUnit, like introducing PHPUnit into their development workflow, helping them optimize their existing tests, help them write tests for existing software to make legacy modernization possible, one-on-one coachings, group coachings, and traditional training. And there's also open training, meaning training that you can book where people from different companies are in. Of course, we can then not go into your specific problems, and I bring examples to that to exercise and learn, but that is an alternative option.
I see. So if so me as a developer, I can support you just by going into GitHub, finding PHPUnit and click sponsor. Companies, the benefit, they can actually go straight to you and work out some kind of plan, and the benefit for the companies is they've got all the VAT receipts and everything, proper invoices for company to company. And then you offer training as well. So for example, I could sign up to what we could either get you in, so the company to do like company bespoke stuff, but also I could just sign up online to one of your training courses, and we would find those all on which website are they all on?
So the open training, that's on the phpcc.academy.
Okay.
And probably easier to remember is my landing page for my professional consulting coaching training work, which is phpunit.expert.
Excellent. Great web address. Yeah. So we can go there and sign up on. And are these courses, do you download them or are they're live courses?
All of my training is live courses. It's interactive. It's not pre-recorded. It's basically, when we come to technical implementation details, it's a Zoom call. And like an introduction to PHPUnit training that is 4 2-hour sessions with me, where it's a mix of formats. It's me explaining something, me demoing something. I rarely use presentation material like slides in my training. It's always hand-on and live coding. And attendees of the training get exercises.
Oh, I see. So you do a 2-hour block, then there's some time for you to practice what you've learned, and then the next 2-hour block.
There are 2 ways of doing the exercises depending on the training. Sometimes it is within the 2 hours, there is like a 20-minute block where I give you a task and you work on that task, and I'm there in the background via private chat to answer questions during that 20-minute quiet time where everyone is working on their task, and then we get back together and discuss what we learned, what the problems were, and so on. There are training courses where there are slightly larger task assignments between 2 sessions. So you have a couple of days to fit that into your schedule and work on those tasks. It's usually not something that should take longer than 1 hour because time is precious for everyone. But I think like in 1 week between 2 sessions of a training, you should be able to fit in 1 hour to work on that assignment.
Yeah. Fantastic. Brilliant. So those are like some of the ways, super beneficial. Not only are we supporting you, but also we'll be learning a lot as well. So we'll make sure all those links are available for wherever you're watching this video. And I'm very much looking forward to your talk. I can't help thinking if I'd watched it 7 years ago, that would have made my life a lot easier on one of my projects. But
if it makes you feel any better, 7 years ago, I would not have been able to give the presentation.
Right.
For 2 reasons. One, 7 years ago, that would have been before PHPUnit 10 and its event system. There is that term again, but I use it in a different context. So PHPUnit, ever since PHPUnit 10, PHPUnit has an event system under the hood where PHPUnit emits an event for everything that happens while it is running your tests. And that is the foundation for building extensions for PHPUnit. And all the output that PHPUnit generates comes from subscribing to these events and printing output, like the dots and the F and the E and whatever on the command line or log files. All that comes from the event system. And I will show in my presentation an extension for PHPUnit for testing event-based systems, so that running your tests for your event-based system automatically generates visual documentation for your event-based system. So that is one reason why I would not have been able to give you the presentation 7 years ago, because that extension mechanism for PHPUnit did not exist back then. And the other reason is, while I already knew about event-based systems and event-driven systems 7 years ago, I would not have been comfortable enough giving a presentation about it. But ever since then, I've had a lot more experience with that, both in the software that I build myself, in software that I help other teams build, and of course also with the event system in PHPUnit. That also helped a lot.
Yeah. Well, I'm really looking forward to this talk. It's going to be the first time you're giving it?
It's going to be the first time that I'm giving this particular talk, yes.
Fantastic. Brilliant. So I'm really looking forward to this. It is going to be on February the 20th, 2026 in London. And yeah, I look forward to seeing you there. Thank you very much.
You're welcome. I look forward to being in London as well.